Hello and welcome to this Azure Synapse Espresso. Today we'll be talking a bit about performance and we'll do basically a deep dive into Parquet files. I'm joined here again by Serverless SQL Pool team member Filip Popovic, and we will talk about what a Parquet file is, how it is built, how Serverless SQL Pools interact with it, and how you can save money and increase performance by knowing all these things and thinking about how you're going to structure, order those files to make it go faster. So, first of all, I would like to kick off with giving you a brief explanation about what a Parquet file is. Now, as you can see here, we have the structure of a Parquet file. Every Parquet file will start with the same number, which is called a magic for number par1, and it will have the same number at the end. So there's par1 at the beginning, par1 at the end. At the par1 at the end, just before that, there is a footer length, basically telling you how long the footer is, which contains your metadata. It will basically then tell you inside that footer length, you will have information about the format version, the schema of your file, key value pairs, and column metadata. And then there's another part, which is basically your data part, and your data part is constructed out of row groups. So you'll have a row group 1, for example here, row group 2, and each row group will contain columnar chunks, which means we can potentially read only row group 1 and only columnar chunk 1 based upon the metadata we have in a Parquet file. So, a quick question for Filip. How does Serverless SQL Pool handle these types of files?
So Serverless SQL Pool first needs to make sure that it's actually reading Parquet file, and it does so by reading this Parquet magic number from the beginning of the file, and then going to the very end of the file, reading the Parquet magic number once again, and reading of length of the metadata. Then it does the backward seek and reads the actual file metadata, and only then starts reading the data. These operations are not slow, they're actually pretty quick, but you can easily imagine if you have many small files, this can easily add up, right? Because this needs to be done for each and every file. So ideally you don't want to have many small files like Parquet in kilobytes or maybe even megabytes, but something around a few hundred megabytes or 500 megabytes is quite fine for a Parquet file.
Okay, so basically Serverless will read the metadata. Based upon the metadata, it will choose to read either row group 1 and also which columnar chunks to read. So it can do all that pass-through of that data and just read the parts of data that we need. Okay, but as always, I would like to show you how that works. So let's head over to my desktop here. So you can see here, I have sort of a notebook ready. And a notebook is basically a Spark-based a thing you can use to query Parquet files. And why am I using Spark in this video is because I'm going to show you something specific called PyArrow. And inside PyArrow, you can load in one of those Parquet files and read the actual metadata of those Parquet files. Now, as you can see here, I'm just loading in a Parquet file. You see that it did that. And then, based upon that PyArrow data frame, I can just say, hey, give me the schema. As you can see, it gives me the schema, and it also tells me, for example, I have int32 in here, int64 over here, but I want to focus a little bit on the PU location ID. I've specifically created this file, and I've ordered the data inside of that file based upon PU location ID. Now, as you remember in this slide over here, you get row group 1 and each columnar chunk that is in there, but each row group can be loaded in a sequential way, which basically means that row group 1 will contain only a part of the PU location IDs, and row group 3 will contain a part of the PU location IDs. Now, I can go forward and query that metadata, and it tells me this file in specific has about 20 columns, and it contains about 168 million rows, which consist of 35 row groups. Now, I can go and check at row group 0, column 6. As you can see here, if we count, this is column 7, but this is starts at 1, while this specific one is 0-based array, so it starts at 0. So 6 is the PU location ID. As you can see here, it tells me the PU location ID, and it gives me the statistics, and it tells me that the values inside this row group, so row group 0, the first row group, has values 0 to 7. If I go and look at the same one for row group 1, you can see that a 7 here starts and it ends at 15, which means that PO location ID 6 will only be in row group 1 and PO location ID 7 will be in both row groups. Now, as Philip told you just a moment ago, if we're going to query those files, if we're going to query that specific Parquet file, which we're going to do in a second, if we say where PO location ID is 6, we should read less data than when we would say where PO location ID equals 7. So let's head over to our next demo, which is on SSMS. Also, something cool just to mention, we didn't say that in any of our previous videos. This is a SQL endpoint, which means we can connect with any tool, which means we can just connect with SSMS to that serverless SQL pool. Now, as you can see here, I am reading a CSV file, which is basically the same file for each one of them. And the CSV file, and I'm doing the PO location ID equals 6. For the first one, you can see that I'm scanning 61 gigabytes of data for the same result, and it takes about a minute to execute that query. Then the second one only reads 121 megabytes of data, and as you can see, that's over here, PO location ID equals 6. And remember, 7 is in 2 row groups, which means that we're reading more data. And you can actually see that. Over here, we're reading 2 row groups, which is a total size of 241 megabytes, while the previous one only read 121 megabytes of data. So we basically have row group elimination inside our serverless SQL pools. Now, Philip, will it also do columnar-based elimination?
Yes, Stan, as you mentioned, data within row groups is organized in a column chunks, meaning that each column can be read separately. So if you reference just a subset of columns in your query, then service will be able to read just the columns from the file that you're interested in and ignore all the others, not read them at all, just skip. And that way you will improve the I/O, reduce the I/O, improve the performance, and finally reduce the costs.
Okay, cool. So let's take a look at that. Over here, you can see that I've only read a subset of the data. So previously over here, you can see that we read about 121 megabytes of data when we did a select star. Now here, I did not do a select star. I just did, I'm just selecting a few subset of the columns. So I'm just going to execute this query real quickly. Should not take too much time to execute. And then go to messages. And you can see here, indeed, because we only select half of the data, we're only selecting 88 megabytes of data. So we basically reduce the amount of data that we're reading from, if we look at CSV, let's head over to the CSV, we go from 61 gigabytes of data to 121 megabytes of data when we do a select star. But as always, it still goes up, only select the columns that you need. So let's say in this specific query, we only need this set of columns. We reduce the amount of data that we're reading again. We enhance performance because we read less data, and we also enhance the cost that we're spending. Okay, now, Philip, basically, using these tactics, we can greatly improve the performance of our serverless SQL pool, right?
Yep.
Because we read less data, reading less data means less complexity for the engine, which means that we don't have to process that amount of data. If we use less resources, we pay less, and we are working in a more performant way. Now, to quickly show you what the difference is between these different sets, let's head over here. So a Parquet file executes about 14.5 times faster for this specific example, and reads 191 times less data than the CSV file execution. So basically looking at size, execution time, and the amount of data read, Parquet completely outperforms that CSV file because it can do that row group elimination and can do that column elimination. So as always try to use Parquet files instead of CSV files, because Parquet files are clever enough to basically skip parts of the file using row group elimination or skip parts of the column by using column elimination. And the combination of both will give you the best of both worlds. So anything else to add, Philip, on this thing?
Well, I think you summed it up pretty well. Basically, as we mentioned in the previous posts, we would always prefer Parquet because it's compressed. And now you just learned that we can leverage row group elimination and the column elimination in your queries if you're using Parquet file. So quite dramatically reducing the I/O and improving performance of your queries.
Okay, perfect. So that concludes this video. Thank you very much for watching and hope to see you in the next one. Bye.